you, everybody? I'm Evan Chen from Phoenix Technology. So I'm here to talk about the better video performance in Preboot. So I will introduce what is the hardware bitrate and why we need hardware bitrate and the enhancement of GOP driver. GOP driver is a graphic output protocol. Okay. And we have some video and show you the difference between the hardware bitrate enabled and disabled, so you can see the difference. Okay. So what is the bitrate? Bitrate is bit block transfer. You can see this word in many SDK, just like Windows 32 or other SDK. And the purpose of this function is to move a block of data from the source to the destination. And we always use this function to move the image from the system memory to the video buffer. Okay. So bitrate, actually bitrate has many sub-functions. This function provides some register option, just like AND or exclusive, or it manipulates your source image to the with the destination image. Okay. So here we are talking about hardware bitrate accelerator. So the hardware bitrate accelerator is always provided by the VGA card, and he uses the hardware method to move the data from system memory to video buffer for you. Always the case. Sorry. Okay. So, and furthermore, we want to talk about hardware bitrate accelerator supported in current GOP. Maybe you already know what is a bitrate. Just like I mentioned, the purpose of this function is to move data from system memory to video memory. There are two methods actually to move the data between these two regions. The first one is software method. What is the software method? Maybe you can use UEFI copy memory and to move your data, your image from the system memory to the video buffer. Or you can use some low-level language for a better performance. Just like you can use x86 assembly language, okay, to use a repeated move, and you can get better performance. Or you can use some MMX, SSE. Those are multimedia instructions. You can use a large register. For example, SSE, it is 16 bytes length register. So it means you can move the data in 16 bytes in one instruction. So by using this method, you can have better performance. However, even though you use the software, even though you use the assembly language, the performance is fine, but it's not enough. Okay. So if you have a hardware method, then you use a hardware to move the data for you. So it's very fast. So that is the difference between the software and hardware bitrate. And the current GOP, I think, all GOP driver from silicon vendor is use software method. Okay. And why we need hardware bitrate? Actually, we need a better video performance for the modern and emotional UI experience. I believe many people now, even in the IBV or third party, they need some application on the UEFI environment with GUI supported. They want to give the end user new experience when they use their application. So, if you want to have a emotional representation, then you need a better video performance to refresh your screen. So here I will show you these two cases. This one is traditional BIOS setup. This is test mode like BIOS setup. Why I say it is text mode like? Because actually this BIOS setup is shown on the graphic mode, but it is text mode like. And if you use this type of representation, this is a statical user interface, and I'm sorry. You can see this is statical because I think maybe 2 frames or 3 frames per second is enough for this look and feel, because it doesn't require the faster refresh rate for update video screen. It is not an animation, or it doesn't have some special effect require the better require the video performance. However, if you want to have a representation like this, this is a graphic mode setup in Phoenix BIOS now. And if you want to you want to have a motional user interface, then you need better video performance to refresh the screen. Then you can get a smooth effect. You can get a smooth user experience and no lags. You can see when we drag the tile, then it's very smooth. Even though I drag it quickly, you must update screen very fast. And you can have some effect. You can drag the widgets, and everything looks very fast. So if you want to implement such kind of user interface, then you need faster video performance. However, in this case, we actually use a software method. We didn't use how we build it. Then we use some assembly language to get a better performance. But if you want to, the video mode is 1024 by 768. So for this size of a video resolution is enough if you just use the software method. However, if you want to support HD resolution, then it's terrible because it's a bunch of data you should move from system memory to video. So that's why we are talking about how we build it here, because we want to provide end user a motional, a new experience when they use the user interface. Okay, this is the first reason why we need a how we build it. And the second is just I mentioned, a bunch of data transfer between system memory and video memory. If you are using 1024 by 768 video resolution, then there are 3 megabytes. If you want to refresh your screen, a full screen, then you must move 3 megabytes from system memory to video buffer. And if you want to have a 10 frames per second or 15 frames per second, then it's a huge data. And I mentioned in the previous case, I showed you we use software method, and everything looks fine and good. However, if you want to have a UI have the same thing in the HD resolution, then they are 8 megabytes. We have to move from system memory to video buffer for a frame. So if you want to have a smooth representation, then you need very fast algorithm to make it. So this is what we can do to use the assembly language and get a fastest performance. We use XML register to move data from system memory to video, and that is 16 bytes in one instruction. This is what we can do, no more. So for supporting the GUI, motional GUI in a HD resolution, then this method is not enough. So that's why we are talking about how we build it. Okay. And for some low-cost platform, it's terrible too. Our GUI actually can have a good representation on River, on some MD platform, but it's not good in some low-cost platform. And you know what is low-cost platform? Low-performance platform. You know that. And we must tune some special effect, just like screen flip. We must reduce the frames and reduce something, and then we can get an acceptable representation. So for those kind of low-cost platform, we need hardware bitrate, just like Windows, Microsoft, or Linux. They use a hardware bitrate in their under their OS environment. And for the portable UI code, you just saw we have a piece of code and it use assembly language. However, this could not be portable code. If you want to support ARM-based platform, you have to use ARM multimedia command. So for IBB, we must write many low-level code, low-level UI code for different platform. So it's difficult. So those reasons, because of those reasons, so we need hardware bitrate to give user a new experience when they use our application. So enhancement of GOP bitrate. First, there is no spec change on GOP bitrate. Actually, this function, there are so many options for this function, just like rest option or some other functions. But what we need is just system to video and video to system options. So if we can just provide a hardware bitrate in those sub-functions, then it's fine for now. So there's no spec change for the GOP bitrate, and this is not specific to any IBD. When the when the hardware bitrate is available, then every IBV, any end users, any third party can get benefit from this from the hardware bitrate. And it's difficult for the IBV to provide hardware GOP bitrate. The demo you just saw is on River platform, and the hardware bitrate is written by ourselves. Of course, we refer to some open document from the internet. However, after we finished the hardware bitrate on Sandy Bridge, we found it can't work on Ivy Bridge, even though they are River. On Ivy Bridge, there are some garbage when we move the image. So actually, each VGA card gets the different VGA engine and different implementation. So it's very difficult to IBB to implement the hardware bitrate for every VGA card. So that's why we talk about hardware bitrate in this Plugfest. We would like someone's help. Someone is IHB's help to implement the hardware bitrate for us. And we are not no immediate requirement for the 3D acceleration. 3D maybe it's not for now because we are not try to write a 3D game or have a Photoshop in the UEFI shell. Okay. And not required for the 2D accelerations except bitrate. We don't need a mapping texture render, 2D texture render for now, but we just want a high performance when we want to move image from system memory to video after. So due to those reasons, so we need HIV effort to implement hardware bitrate function for us. The IHV here I mentioned is just like Intel, NVIDIA, or every VGA vendors. They can implement hardware bitrate easily because they have the same experience to provide driver under Windows, under Microsoft Windows or Linux. So they can just copy the source code and pass it to UEFI driver any source code and then build it, maybe it works. So I guess that is not a big effort to provide this kind of feature on GLP driver. Okay. So I have two demonstrations for you to see the difference between software Preboot and hardware Preboot. And you can see the difference and you will know why we need this. This is a software Preboot, and I load our utility, and you can see when I drag the windows, it looks fine. And actually, it is software Preboot only, not hardware Preboot. And here you can see we have a software Preboot. I'm going to uncheck this. Oh, I have to test the Windows mode first. And here you get the result. 1 and 6 seconds to move a window in this size, 600 by 700 pixels, and for 100 times. And it takes 1 and 6 seconds. Okay, and then I will uncheck this option and apply it and test it again. You can see it's different. Can you guys feel about it? The speed is much different, and it takes only approximate to 1 second for the same size of window for 100 times. So it's almost half. Okay. It almost half compared to the software Preboot. And this is a hardware Preboot. It is very small. And if we don't use hardware Preboot on HD resolution, and if I want to try, I want to move huge windows, then it looks slow. And then this is another demonstration for the graphic effect. Here I show two graphic effects. One is screen free, and another is image blur. Okay. Both of those two graphic effects, it must refresh screen, full screen. So we can see the difference between software Preboot and hardware Preboot. Okay. This is the screen free. And you can see it looks smooth even we use software Preboot. Okay, I'm trying to show here it's blurred. Okay, we update the screen also. And now, okay, we can see the performance here. It takes 600 millisecond for the screen flip for 30 frames. So the effect you just saw is 30 frames. Okay. But you can complete it in 600 milliseconds. And the blur is 1 and 50 milliseconds. But the blur is only 5 frames. Of course, those graphic effect is not only Preboot. There are some mathematical calculation So we still use the software method to calculate, to have the mathematical calculation. So when I enable the hardware bit, the difference is not so huge. Okay, and then I will uncheck the hardware bit. And flip the screen again. You even cannot catch it, right? It's very fast, and it's 30 frames also. And I will try to have a screen blur. It's faster. Okay. So you can see the different measurement. It's also half compared to the software library for the screen flip, and it's faster for the screen blur compared to the software library. So if your application doesn't use some special graphic effect, or you don't require the faster screen flash, of course you don't need to have a hardware bitboot. But if we have hardware bitboot, then what can I have? In this case, we use 30 frames for the screen flip. But if I can have a hardware bitboot, I can use 120. I can do more if we have the hardware bitboot support. So I'm here to change the frame. Currently is 30 frames, and now I'm going to change it to 120. Okay, here I use 120 frames for the screen flip. So you can see, once you have the hardware bitboot, you can do more, and you get benefit from the hardware bitboot. And you can do many modern UI. You can have a modern UI, you can have a modern graphic effect to give end user the new experience when they use the UEFI application on the UEFI ship. Okay, so please visit Phoenix test room for more detailed information about our GUI or Bitbury. This is a new thing. For our Phoenix BIOS. Can I say it? Okay. This is our graphic BIOS setup. So if you are interested about our graphic GUI setup, then come to our testimony for it. Okay, thank you.